Okay, the next team is Team 6. The customer is Schlumberger-Doll Research in Cambridge, and this is Team ECE.
Alright, so we're Team 6 IC Analyzer. I'm Catherine.
I'm Mike. And that's Matthew.
Alright, so our project objective is to create a mobile Android application for Schlumberger that takes gas chromatography data and changes it to NMR data and vice versa. So currently Schlumberger uses computer-based software to go between these two data types. There's no really quickly accessible or mobile tool to perform the same function. So the idea is to give the user a rough idea of what they should be expecting before they start an analysis. So for example, an engineer in the field may be about to collect NMR data on a well, but he wants to see what he should be expecting. So if he already has GC data from, say, a nearby well, he can run this through our app and get a basic idea of what he should be looking for with the well he's currently working on. So this is a little bit of background for those of you who are not familiar with gas chromatography or nuclear magnetic resonance. So gas chromatography is a method used to separate the different components of a mixture to determine the relative amounts of each component. So in this example, gas chromatograph, you can see here there's a C15 group. So that means all of these peaks right here correspond to molecules that have 15 carbon atoms. So the C15 is just what is called a carbon number, so we'll be referring to that later. So that's just what that is. And so our app takes these carbon numbers and the relative weight percents in the sample as its GC input data, and it also outputs that as GC output data. So nuclear magnetic resonance spectroscopy, or NMR, is a technique used to determine physical and chemical properties of molecules. And our app uses diffusion coefficient, which is this data here, and T2 relaxation time, which is this data here, as again it's input and output NMR data. And diffusion coefficient is just how fast molecules diffuse, and the T2 relaxation time is the time for a magnetic resonance signal to exponentially decay to 37% of its initial value. So it's just a time passed.
So our deliverables, we need to have a working Android application ready to use installed on our Samsung Galaxy Player, which was supplied to us by Schlumberger. We'll be using this for debugging purposes and everything. We need an executable file ready for distribution. This is like the main reason why we decided to go with Android over iOS, was because of intellectual property issues. So with iOS, you have to go through their app store in order to get the application. And we don't want to put it up on the app store. We want to have it in its own APK file that they can distribute on their own private network. And then documentation. So a user manual explaining how to use the application and initial setup. And then a technical manual. So this will explain the code structure and everything, so Schlumberger can go in and modify it if they need to.
And specific to our app, the app needs to be able to take in data both manually entered directly in the app and data that you might get from a lab, which could be in a text file, values separated by commas, or an Excel spreadsheet. So it needs to be able to extract GC data and NMR data both from these data types, and they'll have different requirements. For the GC data, we'll have molecule names as well as the amount of the molecule, and for NMR, we'll have the relaxation time diffusion, distribution, then the diffusion distribution. And we'll be doing error checking on the manually entered GC to make sure that it adds up to a reasonable amount. And in addition, we need to have the temperature and the pressure of the check sample, so that will be additionally on the app. Oh, the algorithm internally expects pressure in bars and temperature in Kelvin, so you might not have that specific type on file, so you can enter it in Fahrenheit, Celsius, and then PSI, kilopascals, and program will convert it appropriately. And then once we've done our modification of the data, converted it to whatever it needs to be, we're going to display the results in a graphical form. The user, for convenience, should be able to switch the graph axes, choose the line color, and choose the units that are used in the NMR output graphs. Additionally, you should be able to save the generated data, and additionally, if you manually entered the data, it's kind of a pain, so you're able to save that if you want to be able to use it later.
Okay, so this is a high-level block diagram about how the application works. The user is first going to put in their data here, either GC or NMR, and on the same page, they're going to be able to put in their temperature and pressure. So from here, we'll go into the input, we'll do some data pre-processing, a little error checking, then we'll go into the actual algorithm, we'll do the conversion to the other type of data. From here, we'll go up to the graph generator, which will then ask the user for more preferences on like which axes they want the graph to be on, as well as the labels for the graphs. So then after they submit that, we'll go into the output display, where you can see the NMR output, if you put a GC or vice versa. And,
All right, so the two features that aren't obvious from looking at the GUI, the user interface that is, are the input processing, which is what actually takes the plain text files and the Excel spreadsheets that I was talking about and reads them in and hands it to the algorithms in a way that the algorithm is going to understand. This is pretty basic. We just have something that, you know, if it's a plain text file, it's separated by commas, and then each line corresponds to a row, much like a spreadsheet would work, and it just scans through that. And then we used a simple Excel library called JXL, which is open source and under the lesser GPL, so it's okay that we're using it here, which parses the Excel much in the way that we text. And then the data conversion is the actual heart of the application. This is what converts NMR to GC and GC to NMR. These were provided to us by Schlumberger in MATLAB form, and we converted them into Java programs to be able to use them on Android in this app.
All right, so we're just going to go through a quick walkthrough of the app. So this diagram here is a flow chart showing all the different activities. So the activities are essentially the screens or pages that you see on your device. So this top section here is the GC to NMR, and the bottom is the NMR to GC. So as you can see, they're both pretty similar, but the GC does have this extra thing that has to do with how we pre-process the data from a file. So if a molecule name is unknown or a carbon number is unknown that the preprocessor isn't sure how to deal with, it will display this to the user and ask for user input. So we're going to go through just the GC track to demonstrate that. All right, so when you first start up our app, this is the screen you'll get. This is our welcome screen. So if you push the button to start, you're brought to this next page where you can choose which type of input data you'd like to use. So in our case, we're going to choose the GC input data, which then gives you another set of options to choose to either manually input the data or input or use a file and get the data from there. So if you decide to manually input the data, you'll have to enter all the points from C1 to C30 plus. So obviously I haven't shown all of that because that's quite a bit. And at the end, you'll put in your temperature and pressure, choose which units you'd like, and either verify, save, or submit. So because we're going to use, where we want to demo the error checking, we're going to use actually a file. So this is the page that you're, if you had chosen input spreadsheet that you would see. If you press the browse button, it'll bring you to our file navigation system. So if we choose download and weirdgc.txt, it'll give us this confirmation. So we're going to click OK. It automatically puts that file name back into the text box, and we can enter our temperature and pressure, choose the units, enter which column to use in the spreadsheet, and also which sheet, like page if you have an Excel file with multiple pages. And then if we press verify, it'll show us the contents of the file in graphical form, just so you can make sure that you've chosen the right file. back, we go back to the same page. And if this time we press submit, it'll now pre-process the data, realize that there are these three, obviously not molecule names, and present them to the user to say, hey, we don't know what these are, please tell us what carbon number they should be. Since they're not actually real, we're just going to enter zeros for all of them, which means that our system will ignore them. And press submit, and it brings us to the graph preferences page. So here's where you can choose all those different options for how you want the final graphs to be displayed. So you can choose the line point color for each graph, which axes you want the data on, and units. Because these are NMR graphs, there are going to be two of them. There's going to be the diffusion coefficient data and the relaxation time, which is why there's two sets of these preferences. And if we press submit, this is our final output. So all these graphs have zoom, like pinch to zoom, multi-touch features. You can pan or scroll, I guess, and you can also save the data. So the manually input numbers can also be saved, but the process is the same, so we're only going to show here. So if you press the save button, you'll be prompted to enter the file name, and all the data will be automatically saved into a text file and saved on the device's memory, and you can access that and later actually read in that same data that we've saved back into the app. So we'd like to thank everyone we've worked with at Schlumberger, and all the faculty and staff at Clear Design.
Since this is a cell phone app, you have the possibility of a spreadsheet input. Where is the spreadsheet? How do you get the spreadsheet into the cell phone?
Email. You just download the email.
Or if you have Dropbox on your phone, you can do that.
Or if you have some other way to put it onto an SD card, just put an SD card.
Do you see other applications for this?
Sorry?
Do you see other applications for this other than what the customer had in mind?
I'm not sure I understand what you mean. Like if you wanted to.
So in terms of marketability, do you see this being used in different sectors or different markets?
They actually, Schlumberger wants to keep this internal because these algorithms are in some form of market. So they would just, I mean, they're not really looking for marketability, they're just looking more for ease of use and having an additional tool for their engineers to use.
When you get your output graph, can you like click on a certain point and it'll give you like your X and Y values or okay, it's just an image or
Yeah, it's just,
So which version of Android are you building for? And what were the motivations for choosing this?
so it's built for 2.3 and up. We chose 2.3 because the device they gave us was used gingerbread, but it is upward.
So this is basically a port, right? You ported an application that they had to a new platform.
In essence, it wasn't this comprehensive. It was essentially two MATLAB scripts.
Okay.
Yeah, and then we built a whole user
The
interface.
user experience is all new.
Well,
Yes,
also
yeah.
the
And
algorithm
it-
has changed from the MATLAB code to Java.
Yeah, and the additional feature of being able to read in CSV files and Excel files.
Why mobile? Do you use the WildNet or something?
Yeah, so they do have the software, obviously, the MATLAB code on computers, but they wanted something that was a little bit more portable and be able to just give you a quick idea of what's working.
For out in the field.
Sorry.
For out in
Out in the field or in meetings where you don't want to go to your test
Yeah.
case.
Just to follow up to Elias's question, what Schlumberger provided to you was a desktop set of MATLAB files. So one of the things that you had to do was to convert it to Java. Can you say something about how you validated the accuracy of the conversion?
Sure. I wrote this small Ruby script that I had extracted the values that the MATLAB version of the algorithm outputs and then generated the same outputs or what the output would be for the same inputs for the Java program. And I wrote the small script that ran through both of them, compared the values in a scaling way. And the reason I had to do that was because Java's output of floating point numbers has a different precision than MATLAB's output. So you have to take a ratio of the two numbers, make sure they're close enough to 1. Yeah, the output was fair enough for Schlumberger.
Was Schlumberger happy with what you did?
Yes.
Did a customer was happy?
Yes, yes.
One final thing, one other thing. You say you have error checking. Can you tell us what kind of error checking you have?
Okay, so like if you're putting in the inputs manually, you're putting in a percentage amount, so you're gonna have to check to make sure you're above 99% but below 101%. So you have a small percentage of error there. You're gonna make sure one input isn't over 100%, and you're also gonna check for negative numbers. So if any of those errors come up, you'll get us an alert, so it'll tell you that something's wrong. That's okay.
Do you check for the chemistry when you're entering the C number? Like if it's a C12 or a C13, it can only be this, or you don't check for that.
No, we don't check for that.
That's self-generated. The minute they
Yeah.
enter C12, the library generates whatever component.
Right. It's assumed that the user knows what they're doing in that regard. And you can, again, there was the visualization thing, so you can do a quick visualize. At some point it's in outer space, enter that wrong.
Does your customer feel this is ready to go to the deployed field?
We haven't asked him yet. Is it ready for being deployed in the field?
We have some modifications to the algorithm that we have to implement, developments that happen after the once that's done.
But what we do have right now is in a form that